In this video, we will just have a quick look on the control structures, so the most common control structures in Python, which we can use in order to modify the flow of the program from sequential to something more interesting and more complex. And we will start with the branching with the if condition, which you already know probably. So basically this the syntax is very easy. I can have an if keyword and some kind of condition. Depending whether this condition is fulfilled, a certain code is executed. If that's not the case, if the condition 1 was not fulfilled, then one can pose a second condition, check a second condition. If this condition was fulfilled, then I can execute another code, and so on and so on. And I can have an else clause at the very end, which would mean that if none of the conditions had been evaluated to true, so none of them was valid, then the default, let's say the default option should be executed. If you want to have a look at that, like a flip chart, then this is exactly how it would look like. We are checking the first condition here, and if this condition is true, then basically code 1 is executed like written here. If that's not the case, if it's false, then condition 2 is checked, and then again, if condition is true, then code 2 is executed. But if that's not the case, then condition 3 is checked, and so on and so on. And at the end, if it's no, then the default condition is checked. It's very important to note that in Python, basically, this constructs which you have here are so-called block constructs closed by a colon. That means that if the code which I write, which should be executed when condition 1 was fulfilled, can have multiple statements. And how does Python know that which statements belong to this if block and which do not? Python knows that because I have to indent it, right? So basically here I have to use 4 space characters indentation to tell Python that code that everything which statements are belonging to the if condition. And how does an block ends? A block ends by the fact that a new line comes where basically the code is not indented anymore. So what does it mean for us? Here's an example which we can try out in the Jupyter Notebook. I have here a very simple test, which is testing a certain answer. And I will just copy paste it into the Jupyter Notebook. And you see this copy pasting is somewhat dangerous in Python because it might end up with the wrong indentation. So let's assume that I have a kind of answer. Answer should be a string, and it should be just here just yes, and then I can execute this thing depending on my answer. And the answer, I'm just investigating the 0th character, so the 0th character of the variable, which is basically just a letter y, and then consequently this thing had been executed because this condition was fulfilled. Therefore the else branch, the second branch, is never executed. However, here the else branch ends because here I have a new line which is basically here indented unindented, so basically it's not indented anymore. That means this line does not belong to the else branch anymore. Now just imagine what happens if I would just indent also this line, and I would execute here this thing again. Then the let's continue would never execute it because it's not considered to be part of the else block, and therefore if the of this condition here is fulfilled, then basically the else block is not executed, and therefore also this line is not executed. Therefore this is super important in Python to make sure that you are using the right indentation, so basically as you really want to do it, and make sure that when you copy paste code, especially like I did before, that you are keeping all the indentations. Also, you should definitely make sure that you are using an editor which helps you to indent the code blocks easily. So this if-else thing can also turn into an if-else expression as shown here. So basically if you have a one-liner, so you have to take a certain expression if something is fulfilled, or if not, another expression. then you can use this short syntax. Please make sure that you are using it only for very, very short and conscious expressions. If it goes over multiple lines, then forget it and use conventional if, which is as good as and much more readable. Good. The if, as we discussed, it needs a condition. Condition, as we discussed in the previous video, these are Boole expressions, so logical expressions. And the logical expression, as we discussed before, can be either false or true in theory. However, Python has basically the property that almost every object has a sort of Boole value. So for example, if you have an integer, if this integer has the value 0, then it's ever, and this 0 stands here in the if, then the if would it would be evaluated to false. So basically then the if would be never executed. If the value is not 0, any other value which is not 0, then it will be considered to be true. The same with floating point numbers. If you have a floating expression which delivers 0.0, then this is evaluated to false. If it delivers any other value, it's interpreted as true. Should be very careful by that, because of course, as we discussed already, any expressions you do with floating point numbers are inaccurate. So even if you have an expression which is supposed to deliver 0.0, it can deliver something which is very, very close to 0.0, but not exact. But in that case, it would be already considered as true. So therefore, you should never have a floating point expression here, but decide it somehow by some other means. So for example, you can use it sometimes to abbreviate things. Whether it's more readable or not is hard to say. But for example, you could say if the remainder, if you have a number and you are basically dividing by 2 and you are looking at the remainder, if the remainder is not 0, then that means this number is an odd number because there was a remainder which was non-zero. Now you can also write it using these Boolean things in Python somewhat shorter. You can say num %2. If this is 0, then this will be never executed. If it's non-zero, then it will be executed. So that would be also one way to say, okay, if the division by 2 gives you something which is non-zero, then print odd. However, as I said, you should be very careful by that, because it's not necessarily readable. For example, you could also combine it with a not operator, with a logical not operator, if you would want to find out whether it's an even number or not. So you could say not num %2. That would mean, okay, here I get a number which is non-zero. If it's non-zero, or if it's 0, if it's 0, the not turns into this would be false, but the not turns it into true, and then this is an even number. The problem with that, it's super compact, but sometimes it's much easier to read, okay, if the remainder is exact 0. So basically the intention is much clearer here, but you should be aware of that it's possible to do in Python. The next construct I would like to go through, that is a for loop. The for loop is something we use it if we want to repeat something as a given number of times. The for loop can be specified after the for keyword by specifying a loop variable, by specifying the in keyword and something which we can iterate over. So basically something which contains items. The iterable object has some special way how it's defined in Python, but many objects where you wouldn't know it from the beginning, but can serve as an iterable object. For example, a string like John is actually an iterable object. So if I say, okay, take the variable car and run it over all the items which are contained in name1, which is the string John, then it turns out that it will print out the J and O and H and N characters. So that means that basically a string is an iterable object, and every iteration will give each of the characters one by one. Okay. Maybe one remark which we have, because we discussed about that, is that before, that if you don't need it, you want to make an iteration, so you want to execute something a certain amount of time, but you are not interested in the actual value of the so-called loop variable, then you can also leave it away by using just an underscore sign. It tells Python and also the readers of your code, okay, I'm making an iteration, but I'm actually not interested in the actual value of the iteration variable. As a basic advice, and this is something you should remember, when do I use a for loop? I use a for loop always when I want to make a certain number of iterations, and I know already in advance, or I have a good guess already in advance, how many times I have to do this iteration. If I want to, let's say, go over an interval of numbers, so basically over numbers within a certain interval, I can use the range function to return an iterator over integers. And the syntax for the range function is that I am specifying from where I should start, I am starting to where I should stop, and optionally I can also specify the step size in which steps I should go there. So for example here, if I'm specifying range 0, 10, 2, that would mean, okay, we are starting by 0, we are going up to 10 in steps of 2. Now when you look here at the numbers which are actually generated by this range operator, you can maybe wonder, why don't I see here the 10? And the reason for that is the upper limit is in the same way as we had with when we are cutting out strings and substrings, so parts of a string. The upper limit in Python is always excluded, so that means I'm going from 2 in the steps of 2 until I reach 10, but the 10 I'm not including anymore, and that's of course the 0, the 2, the 4, the 6, and the 8. I can omit the step size, and the step size is omitted, then of course the step size is 1. So if I'm saying range 0 to 4, then it will give me the values 0, 1, 2, and 3. If I call the range function only with one argument, which is very common pattern in Python, then basically it's interpreted as upper bound. We are starting with 0, so range 4 means 0, 1, 2, and 3. So it's the same as if I had written range 0, 0,1, and this is very common in Python to leave it away if you start from 0 anyway. And of course, if you are selecting here something which is which doesn't give any range, so it's range 4 from 4 to 4, that means that you are starting with 4, you are ending with 4, but because the upper limit is never included in Python, that means that you are not containing any numbers in this interval, and then this would give you basically the empty iteration. The range itself, the range function itself gives you a so-called iterator. So if you want to, and this is also fine if you want just to iterate over it, but if you want to see the numbers actually, you want to visualize the numbers, then there is a trick. So let's just have a test. I am just writing range from 0 to 10, which where actually the 0 I can just leave away, so I can write range 10. And then basically I just get range 0 to 10 back, so basically an iterator object. If I want to see which numbers would be in this iterator object, I can convert it to a list. We will talk about lists later, and then I see that those are the numbers 0 to 9. Okay. Now, if I make a for loop, sometimes it's actually quite nice to stop the for loop earlier than it was supposed at the beginning. So here the example which I'm showing you here is the for loop where I'm letting the variable num running over a range between 4 and 8. That means we are starting with 4. We are not including 8 anymore, so it would be the number 4, 5, 6, 7, and not the 8 anymore. And then I do the following. I'm saying, okay, if the number is here, that the division by 5 gives a remainder, because I'm having the not here, then I should break. So basically that means then leave the for loop, and this is exactly what it would do. It would run over the for loop, and whenever it found then the first number where the division by 5 gives a 0 remainder, it would jump out of the loop. All right, and this is something you can realize by the break. So if you call the break within the for loop, then the for loop is ended, and basically the command execution starts after the for loop. A similar thing you can, or a complementary thing I would say, you can do with the continue statement. The continue statement would jump to the beginning of the for loop and basically process the next item in the iteration, right? So for example, if I'm having something similar as before, but I am now going from 4 to 8, but now I'm checking, and if something division by 5 is not giving a remainder, because I have here a not, then the continue, that would mean, okay, if I find the number 5, which is the only number in this range which has a remainder 0 when divided by 5, continue means, then that would mean that here the statement after that, which is still in the for block, but after this continue, it won't be executed, right? Because this continue will just jump back to the for loop here and do the next iteration. So basically I would get all numbers which are in this range which are not divisible by 5. On the other hand, with the break, when I break, I would get the first number which is divisible by 5, because I would just stop the for loop at that point. The for loop in Python, this is very specific to Python, has also an else clause if you want to use that, and this is executed if the loop is terminated after having iterated over all elements. So that means that you are jumping out of the, not jumping out of the loop due to break or to a break statement, but the loop really run over all the iterations. So for example, if I'm running here the same loop as before from 6 to 10, 10 is exclusive, so not included, and looking for the first number which is divisible by 5, and then I break, so I stop the for loop, because of course in this range none of the numbers is divisible by 5. Basically this loop will make all its iterations and then basically here execute the here the code block in the after the else statement. And this one is basically, here is the equivalent code. Of course you could have also basically you could manage also to implement that without the else statement by setting a variable which shows us whether we have found something or not, and then basically depending whether that's the case or not, printing out some message at the end or not. However, this is much more compact and elegant if you're using the else clause. There's also another kind of loop which is or repetition which is possible, and this is the while loop. And this the while loop is basically, if you use the while loop, a program block will be repeated again and again until the condition here at the beginning is fulfilled. So basically whenever the while loop makes a new iteration, it checks a certain condition, and as long as this is fulfilled, the loop is executed again and again. If this condition is not fulfilled anymore, then the while will basically jump over this code, so skip this this loop code and continue the execution after the while construct. So what can we use it for? For example, this small code shows you we are starting with a number, a variable called num, set to 1, so number 1, and we are basically here executing this loop as long as the variable num is less or equal than 20. And within the loop we are just writing out the value of num and multiplying it by 2, right? And then basically we would do it as long always increase until the increased value is not less or equal than 20 anymore, and then we would continue here the execution after the while, right? And then basically what would this algorithm here do? It would basically give you the first number above 20, the first power of 2 above 20. Of course you could have calculated by other means as well, but it shows you the principle. If you don't know how often you have to do the loop, but you repeat it again and again until a certain condition is fulfilled. And if this condition is not fulfilled anymore, then you are jumping out of automatically. Code execution continues after the loop construct. Also, the while loop has a break and the continue statements, and they are working exactly the same way as for the for statements. So continue would just jump to the beginning of the while loop and evaluate here this construction again. If you have a break statement somewhere, then that would basically, if that is executed, then you would just continue execution after the print statement, right? And this what you see here is a very simple-minded implementation of a user interface, where you are asking the user whether the user agrees or not, and depending on the answer, you do something. If the answer is not yes or no, then you would just say continue. So basically, because the user maybe mistyped it, and then continue means jump at the beginning and do the thing again. And if you get just some answer which you were really looking for, then you can call a break, and then basically you jump out of the loop, right? So but as I said, the continue and the break statements, they work the same way as they do in the for loop. Also, the while has an else which can be executed, and basically the else is only executed when you were leaving the while loop, not with the break statement, but because here the condition was evaluated to false. When that's the case, then the else clause is executed accordingly. Okay, good. And this is basically all I wanted to tell you about the various Python code control structures, because this is already enough to steer the program flow as we wish.